So like what we did with arithmetic series, we want to be able to find a nice formula that will allow us to add up the first n terms of a geometric series. So the sum of the first n terms, which I'll write down as Sn, okay, we've seen this notation before, would be starting off with the first term, which is a, and then the second term is a times r, okay, because I multiplied by the common ratio each time. The second term would be ar squared, okay, and I would keep on writing each of these terms out until I arrive at the last term, which is given by the nth term, okay, which is ar to the n minus 1. Now, for convenience sake, and to show you how this works, I'm going to write down the term that is previous to that, which is ar to the n minus 2, okay? So this is the sum of the first n terms, because that's the first one, second, third, fourth, fifth, sixth, seventh, all the way up to n minus 1 and n, okay? So, how am I going to find a formula for this? Well, there's a little trick to start off with, and what I'm going to do is I'm going to multiply this sum by r. So I'm going to multiply each of the terms by r. So I multiply the left-hand side by r, so I'm going to get a times r. Multiply that by r, I get ar squared. Then I'm going to get ar cubed, plus all these get times by r as well. Times that by r, and I get ar to the n minus 1. And I multiply that by r, and I get ar to the n. Okay? Now, you'll notice that there are many similar terms, okay, as we can see by the diagonals. So there are similar terms, and that allows me to spot that it would be a good idea to subtract Sn from Rsn. So I'm going to take that line and subtract that one, okay? Now what's going to happen is I'm going to get ar to the n, okay, that's going to be remaining. Okay, now the ar to the n minus 1s will cancel each other out, okay, and then I'm going to have an ar to the n minus 2 take away an ar to the n minus 2, so they cancel each other out. All the terms in here cancel each other out. I'm going to have ar cubed take away ar cubed, so they go, okay. Then you can have ar squared take away ar squared, so they go, and ar take away ar, so they go, and I've got left that little a, that singular a. So that is what I'm left with. This looks a lot nicer, okay, this is all right. So what I can now do is I could factorise both sides of the equation, because I can take an Sn out of a bracket and have r minus 1 inside, and I can take a out of these two terms to get that, and then I can divide both sides by the r minus 1, and that leaves me with this formula here. Okay, and that gives me the sum of the first n terms of a geometric series. Now, depending on your value of r, if r is less or between minus 1 and 1, okay, what we generally do is we rewrite this equation, and that can be found by, instead of doing rsn take away sn, you could instead do sn take away rsn, and so you'd be getting a take away ar to the n, so everything would just reverse round. Factorise both sides again, you get 1 minus r inside the bracket, and a lots of 1 minus r to the n, and then divide by the 1 minus r, and you get this formula instead. Okay, both of these are exactly the same, and you're actually given both in the formula booklet. Okay, so this is on the first page, top left, under geometric series. Okay, so this is one that we must make sure we know how to use.